Good morning, everyone. My name is Ricardo Domingues, and now I'll be talking on the research that is specifically addressing attributions of coastal sea level changes along the U.S. East Coast. And the East Coast has been identified as a hotspot for sea level changes, where several locations are actually showing rates of sea level rise that are faster than the global average. As you may imagine, here in Southeast Florida, we're among the most vulnerable locations to the effects of sea level rise because of our very low-lying topography. And we are already seeing recurrent sunny day flooding events that have been increasing in frequency, such as the very extensive king tide floodings that we saw just a few weeks ago. So we want to understand what are the drivers that can contribute to these type of events. There are several factors that can drive sea level to change. We are particularly focused on the effects of oceanic and atmospheric dynamics that can dominate interannual to synoptic scale changes in sea level. The Gulf Stream is a very important player here for our coast. The physics of this current actually sustains a sea level difference of over 1 meter between Florida and the Bahamas, meaning that sea level is actually 1 meter higher in the Bahamas because of the Gulf Stream. And the system works in a way that a weak Florida current transfer is actually associated with an increase in sea level here in Miami that can drive an up to a 20 centimeters increase in sea level. And you may be wondering, well, are a few centimeters really relevant? Here's a picture from 2017 that shows that we are actually very close to the threshold at high tides when we see flooding events. So a few centimeters can help push the water over these thresholds. We use an extensive array of ocean observations to do these attribution studies, and a lot of these components are actually managed here, or we play a very important role on these ocean observing components. One example is the continuous record of the Florida current transport, which provides daily measurements since 1982. And this record allows us to look into the details and changes of the flow of the current. For example, it allows us to identify that strong oscillations in the Florida current intensity from 1997 to 2005 actually dominated the interannual sea level variability observed here in Miami. But this is for interannual timescales. What about the synoptic timescale? A few months ago, we had Hurricane Dorian sitting for several days over the Bahamas, and we kept hearing on the news that we were on the clean side of the storm because the winds were actually pushing the water offshore. But what we saw was a very relevant positive sea level anomaly here in South Florida. And so we wanted to understand what exactly caused that. So AOML actually led a complete hydrographic cruise right after this event, which confirmed that the hurricane actually disrupted the structure of the Gulf Stream, causing the record low Florida current transport, which drove sea levels to be above normal. We also wanted to understand what caused the very extensive flooding events from 2015, which were actually one of the larger on records, and they were associated with the combined contributions from long-term sea level rise, but also very strong interannual changes in sea level. And just to give you an idea of how strong these changes can be, here are the 2010 to 2015 sea level change rates compared to the long-term rates. So these interannual variations can be 10 times faster than the long-term sea level changes. So it's really important to understand what's causing them. And for this particular event, this increasing sea level was associated with warming of the Florida current transport, which caused, through thermal expansion, sea levels to be over 10 centimeters above the average. Further research confirmed that this was actually associated with large-scale heat convergence in the North Atlantic Ocean associated with the meridional overturning circulation. And what we're seeing is that this mechanism is actually playing a very important role in modulating the actual number of hours of flooding that we're seeing here in Miami. And so this is just a quick summary of some of the research that we're doing. These results are actually currently helping for plan for resiliency efforts here in Southeast Florida. And we're also, given the potential contribution of these results to our communities, we're looking forward to working with the National Ocean Service on the helping improve seasonal sea level outlooks, and also with the National Weather Service on the storm surge probabilities and forecasts. We're also exploring opportunities to expand our observing capabilities by incorporating state-of-the-art technologies such as underwater glider observations in this region. So thank you very much.